Thank you very much, Alfredo, for your kind introduction, and thank you very much for the invitation. I'm really happy to be here today to share a little bit my experience on developing an AI-based solution for a really challenging task that needs to be done by the otolaryngologist during the evaluation of laryngeal lesions. So as Alfredo said, I'm a research engineer at the Department of Otolaryngology at the University of Giessen in Germany. And today I will give you a short overview of the project that we are doing since 7 years now. A little bit short and maybe on using the AI technique for the powerful contact endoscopy combined with narrowband imaging for the laryngeal lesion assessment. So I will go a little bit to the clinical problem, what we need to solve. So larynx is one part of the head and neck region, and laryngeal cancer is the second most malignancy tumor in this region. Diagnosis of laryngeal cancer is relying on the application of surgical biopsy, which is an invasive procedure. So the patient has to go through the general anesthesia, and the specimens are taken under the guidance of the microlaryngoscopy procedure. But this is an invasive procedure and causes a lot of morbidity to the patient. That's why in the recent years, the effort is to introduce more minimal invasive procedures for diagnosing and evaluating laryngeal lesions. And as one of the minimal invasive techniques, we can rely on the application of the medical imaging, especially endoscopic imaging. Here you can see the application of endoscopy-based examination using white light and narrowband imaging. You will see the narrowband imaging in a few seconds later. So usually before performing any surgical biopsy, the otolaryngologist evaluate the overall structure of the vocal fold under two different lighting conditions. First one was white light, and now they moved to the narrowband imaging to evaluate the architectures of the tissue and also the architectures of the vocal. There are a lot of studies that show that the changes of the blood vessels that you can clearly see in this video has some information as a complementary information during the diagnosis procedure. But as you also maybe noticed that the application of white light and narrowband imaging, which is the standard application and used now guideline during the diagnosis procedure, cannot provide so magnified and detailed examination or visualization of this type of test. That's where we enter to the application of the contact endoscopy, which is again endoscopy-based technique that provide more magnified and enhanced visualization of the vessels. And evaluation the structure of the vessels here can provide more useful information for the surgeon about the type of the lesion and about the stage of the cancer action. Contact endoscopy-based examination combined with enhancement techniques such as MDI is only used nowadays in the research applications. It's not a standard procedure. However, it is a very strong technique because it's non-invasive, it's quick, they can repeat the procedure, and they can examine the large and multiple areas, and later they can give you the videos and the extracted images. But as you may maybe see also in the next slide that I show you more images, there are similarities between the vascular patterns in this type of images, and this results into subjective interpretations because the otolaryngologists need to have some experience to know how the vessels look like when you have benign cases or how the vessels look like when you have malignant. That results into missing some malignant regions and also performing something in a treatment option that was not so optional for the patient or to the benefit of the patient. So in this area, and in order to improve the diagnosis procedure and also move a little bit towards performing optical biopsy, which is the application of endoscopy-based technique to diagnose laryngeal lesions, we start to work on the machine learning-based technique to have more objective assessment of the laryngeal lesion. Here, I will go shortly through the architectures and the path that we take during our development in the last years. First of all, we use data that I will show you in the next slide, how many data we have collected over these years. And usually, because we are applying two different paths, we need to perform some image processing. Why? Because it's important for us when we are applying any type of machine learning techniques to enhance and improve the data that we want. In the first path, that is more, we call it conventional path, we try to extract some information from the image that are also visualized by the otolaryngologist, because it's easier for them to understand what we are developing. If we tell them, yeah, you see something like that, and we are transferring this information that we see using some mathematical operation, then we feed this information to a classifier such as a Prof image or trainers and they have learn about the characteristics of the image. And also in the next path, we started to move also to the deep learning based techniques to have more forward architectures and models to provide more objective. Because the first part we started to use features, and then there is a lot of manual parameters that you need to set for these feature extractions. But in the deep learning approach is more objective oriented. So we as a human don't interpret too much there, and we let the model itself take all the decisions. And both techniques at the end they arrive to a prediction model we call that can be used as a assistance system during this type of procedures to tell the surgeon about the status of the lesion. Is it benign? You can leave it there. You can check it 6 months later, or if it's malignant, and you need to take care of it immediately. As Axel mentioned during his presentation, the first level of developing any AI-based technique in the medicine or in any area is to update. Thanks to the collaboration that we have, it started with the University Hospital in Magdeburg, and then we went to the University in Giessen. We could collect quite a lot of data during the last years, and we generated a data set that now is publicly available in a repository with the images of 210 patients. These patients have all pathological conditions in the vocal folds, and we took the videos from the operating rooms and extract the images. The data is very rich because it includes the diagnosis of 16 histopathology, 3 malignant, and 13 benign histopathology. We annotate the data also according to the type of the lesion, and benign or malignant, and also according to the leukoplakia condition, which is a very crucial condition that usually occur in the precancerous and cancer lesions. We can see here in the images, the images that I am ordering here usually show from the very benign cases moving towards the little malignant cases. And the structures of the vessels, how it changes when you have malignant cases, for example, like squamous cell carcinoma or high-grade dysplasia, is that when in the benign and early cases you have longitudinal vascular changes, like very where the vessels are changing in the diameter, but when you have malignant cases, you have perpendicular vascular changes, which is visible as loop in the image. And this really helped us during our development phase, especially for the first part, based on the tissue engineering and machine learning. So in the first part, we mainly focus on enhancing the information related to the vascular structures in the image processing stage. That's why we use the certain technique to enhance and also to extract vascular patterns from the images. Then we move to some characterizing these vascular patterns in the image using different techniques. We mainly use 2 techniques based on the geometrical characteristics of the vessels or based on the textural characteristics. In the geometrical characteristics, such as computing the curvature of the vessel, we use different indicators, such as curvature that I am showing here as an example. And in the second approach to use or to evaluate the textual characteristics, we invented actually a new method to actually use a line profile of the image and then plot the intensity value of this line profile, as you can see in this below figure here. And then start to extract features from this. The features that they extracted, we call them geometrical features for the first type of the indicators and also try to set up features for the second of the data. And then we perform machine learning classifications using self-perfect machine, k-nearest neighbor to arrive to the prediction models and to be able to classify everything in analysis. In the deep learning based approaches, as long as we did not have enough data to use and to train the networks from the scratch, we started to use the transfer learning concept that we tested several pre-trained architectures such as ResNet, efficientNet, DenseNet, and other type of VTG19, I guess, and other type of structures. The main reason that we use this type of network is because each of them has some advantages over the other one, and at the end we try to create also an ensemble model of this type of models to be able to arrive to the best performance. Here I'm showing you very briefly the results that we arrived in the last years our development. As you can see that the number of images that we had at the beginning of our project was quite less. That's why these two first studies are mainly focusing on the feature engineering and machine learning techniques. But later, when we started to have more data, we moved forward to the application of the deep learning. And I should say that we are now somehow with more robust model when we are using the application of the deep learning in form of ensemble. So I will now conclude my talk with just mentioning why we need to move toward the optical biopsy. First of all, I should mention that contact endoscopy is really cool, but it only makes sense to use contact endoscopy when it's combined with the standard bite-side and narrow-band imaging, because it's too magnified and it's too detailed that without knowing the full architecture of the workup, it doesn't make sense to use it. Contact endoscopy clearly has some problems. That's why it's not used now in the standard clinical procedures. But we show that if we use AI and machine learning, how the performance can be improved. And thanks to the collaboration that we have with our clinical partners and how they guide us to develop all these techniques, we are really positive that we will start soon the clinical study that we want to do with the models that we develop, to see how these models can improve the decisions during the assessment of the manager. So thank you very much for your attention. I hope I am on time.